This is my second video working on these water batteries, and on the first video, which I'll kind of pan back over here again, I'm electrolyzing water, producing hydrogen and oxygen, but as you can see from the first video, not a lot of hydrogen, but it is working. Also, I found that it's not at all necessary to change the water in these about once every 10 days, and I don't have to put the anodes in CLR anymore if I just wash them off. And I can just keep charging these things up just by changing the water. I've also coated the anodes with a dielectric paste, and in fact I'll show you what that looks like. I've got some more of it right here, and dielectric grease, and that keeps it from rusting, at the same time conducting. Now the problem here is I'm getting very, very little current, about 500 microvolts out of all of this, at about 7 volts, and it's about 3 volts once it goes under the load of electrolyzing. But I am getting hydrogen running 24/7. I've run this now for 3 weeks straight. So I have to find a way of increasing the current so I can increase the amount of hydrogen being produced, and here's what I've come up with. Again, these are about 6.5 inches high with 3 copper cathodes and a zinc-coated iron anode. So what I've come up with is kind of the next step. Come over here to show you that, and that's a much bigger one. That is 32 inches. So where these, when I do a measurement, I'm getting about 500 microamps. On this one, I'm getting 5.07 milliamps, so it's 10 times greater. 10 times greater. So that's going to make a significant difference in the amount of hydrogen I'm going to be able to produce, because of course it's not the voltage, it's the current. So I'll still be producing the same amount of voltage, just 10 times as much current, and in pretty much the same footprint, because these tubes here are about 3 inches across, and this tube is 3 inches across. The only difference is it's 32 inches high. I've got also just one 30 some inch copper tube in there, so if I was to put another copper tube, or even 2 or 3 more, it would increase it dramatically. So again, what I'm working with is a much bigger copper tube, much bigger whole assembly, with an anode and a cathode, but instead of a 6 inch over here, I'm going to a 30 inch. So I'm going to replace all this with 20 of these. It'll give me the same voltage, but it'll give me 10 times the current, which will result in, obviously a significant increase in hydrogen production. Now, let me make this clear again. This is operating 24/7. These water batteries don't wear out. I simply have to change the water. I've done this over and over again now for about the last 2 months, and I'm not seeing any decrease at all in production. As a matter of fact, over a 72-hour period, the decrease in voltage is running right around 2%. And when I empty them out and fill them up with water again, I'm right back up there again. I've also weighed the anodes to see if there's any reduction in their size, or weight, I mean, and there isn't any. And my scale is accurate to 1/10 of a gram. So this is real interesting. This is a way of producing hydrogen with basically a battery system that doesn't wear out. The electrolyte is water, and it's just regular tap water. And what I've got in here is regular tap water with my electrolyte. I put a little bit of lemon juice in there, but very, very little. My cathode and anode in there are stainless steel, so they won't corrode, and they're producing hydrogen. So anyway, I'm going to go to this much bigger one, 10 of these, and hook them all up, or 20 of these and hook them all up. I'll have the same voltage, but I'll have a 10 times, 1,000% increase in current, which will result in a significant higher amount of hydrogen production. Hope you find this interesting. Okay, thank you much. Bye.